Mechanical Drawing Blueprint Your Ideal Design. Hello, everyone. Welcome to our Drawing Recognition micro-class once again. First of all, let's analyze today's drawing. According to our drawing reading steps, the first step is to read the title block. The name of this part is a spacer block. The drawing scale is 1:1. The material is number 45 steel. The second step is to read the views. This part uses 3 basic views. Among them, the front view and the left view can reflect the step structure and the overall height. The left view uses a full section view with a single cutting plane to show the depths of various holes. The top view shows the distribution of holes on the workpiece surface. Next, we'll conduct a shape analysis. The basic shape of this part is composed of a cuboid. On this basis, after milling, we obtain the top surface, bottom surface, stepped surfaces, and multiple holes. The connection relationship between the left and right surfaces is flush. The side surfaces of the front and rear bosses and the side surface of the base plate are not flush with each other. Third, let's read the dimensional annotations. First, look at the overall dimensions. The total length of this workpiece is 100. The width is 80 and the height is 30. Next, look at the datums in each direction. The length and width directions are based on the center of the workpiece. The height direction is based on the bottom surface. Finally, look at the sizing and locating dimensions. The main machined elements of this part are the stepped surfaces and holes. The main sizing dimension of the stepped surfaces is the height dimension of 10. The locating dimension is 60. The sizing dimension of the holes is phi 8. The locating dimensions are 44 plus or minus 0.05 and 80 plus or minus 0.05. Fourth, let's read the technical requirements. The dimensional tolerance for each hole on this workpiece is plus or minus 0.022. There are no geometric tolerances. The roughness requirement for all surfaces is RA 3.2. And in the written technical requirements, it is specified that after machining, burrs should be removed. After analyzing the above drawing, today we will focus on guiding you to understand the composition forms and surface connection relationships of the composite bodies in the drawing. First, let's understand what the composition forms of composite bodies are. Any complex shape can be regarded as being composed of some simple shapes through certain combination methods. For example, such a part is composed of 3 major parts stacked together: the base plate I, the vertical plate 2, and the boss 3. Then, based on this, a small cylinder P is cut from the vertical plate, a rectangular prism Q is cut from the base plate, and an ordinary key R is cut from the boss, ultimately forming such a part. From this, we can see that no matter how complex a part is, it is composed of several basic bodies through 2 basic forms, cutting and superposition. Among them, the superposition type is a combination method where the surfaces of several basic bodies overlap, are tangent, or intersect to form a whole. As shown in the figure, the bolt body is formed by superposing a cylindrical basic body and a hexagonal prism basic body. As shown in another figure, the part is also a typical superposition type composite body. It is stacked together by the base plate 1, the vertical plate 2, and the left and right ribs 3 and 4. Then, simple cutting operations are performed separately. Finally, such a part is formed. The cutting type is a solid formed by cutting off several small pieces from a basic body. As shown in the figure, the part is first formed by a rectangular prism 1. First, a semi-cylinder 2 is cut out from the middle of the upper surface. Then, a triangular prism 3 and 4 are cut out from the left and right sides, respectively. Finally, a small rectangular prism 5 and 6 are cut out from the middle. And ultimately, the most common composite body is obtained through a combination of superposition and cutting. For example, the part is shown in the diagram. First, it is composed of 3 superimposed parts: the base plate 1, a rectangular prism, the vertical plate 2, an upright rectangular prism, and the boss 3, a combination of a rectangular prism and a half cylinder. Then, a small rectangular prism 4 is cut out from the center of the bottom surface of the base plate. Next, a rectangular prism 5 is cut out from the back of the vertical plate. Then, a small cylinder 6 is hollowed out from the front boss. Ultimately, this forms the final part. This is a typical example of a combined superposition and cutting process. This form is also the most common combination type in mechanical parts. Through the above analysis, we find that in the drawings of this task, it can be understood as a typical combined cutting assembly. First, based on rectangular prism 1, rectangular prism 2 is cut out from both the front and back surfaces. Then, 9 cylinders are cut out from the top surface and stepped surface to form holes. Meanwhile, this combined form can also be interpreted as an integrated structure. First, a small rectangular prism 2 is superimposed onto the middle of the bottom rectangular prism 1. Finally, 9 cylinders are cut out to form holes, resulting in the final workpiece. Now that we understand the combined form of the assembly, let's analyze in detail the surface connection relationships between the combined parts. The surface connection relationships between parts mainly include 4 types: coplanar, non-coplanar, tangent, and intersecting. How are these 4 connection types distinguished and represented in technical drawings? Next, we will introduce the drawing conventions for different connection forms in detail. First, let's examine the coplanar and tangent connection types. A coplanar connection means the surfaces of 2 objects are flush. At the flush location, no dividing line should be drawn in the projection drawing. For tangent connections, since the tangent line is not a contour line of the shape, it should not be drawn in the projection drawing. For example, as shown in the diagram, surfaces 1 and 2 are coplanar. Therefore, there are no lines at the superimposed junction in the physical object or the 3 orthographic views. The left and right ribs 3 are tangent to the cylinder 4. Therefore, there are also no lines at the tangent location in the physical object or the 3 views. For example, as shown in the left side view and top view. After the sides of the original shapes 1 and 2 intersect, they are obscured by the ribbed plate. Then, in the top view, should the solid line here be changed to a dashed line? Now, please pay attention. This is the area where mistakes are most likely to occur. When shape 3 and rib 4 are superimposed, the 2 shapes merge. There are no lines inside anymore. Therefore, in the top view, there are also no dashed lines here. Next, let's look at the non-coplanar connection type. Non-coplanar means not flush. If adjacent surfaces are not flush, a dividing line should be drawn at the junction. When shape 1 and shape 2 have non-coplanar surfaces, that means not flush. Then there should be a line here. Similarly, rib 4 is tangent to cylinder 3. Therefore, there are no lines at the tangent location. Furthermore, let's examine the intersecting connection type. When the surfaces of 2 basic shapes on an assembly intersect, An intersection line should be drawn at the intersection. When the rib is not tangent to the cylinder but intersects it, it means not only surfaces 1 and 2 are not flush and requires an intersection line. Meanwhile, since surfaces 3 and 4 also intersect, an intersection line should also be drawn at their intersection. Through the above analysis, we find that the assembly in this task's drawing is combined through coplanar and non-coplanar connections. In this assembly, the boss and the base plate are non-coplanar in the front-to-back position. Therefore, there should be a line in the front view. However, the bosses on the left and right sides of the workpiece are coplanar with the base plate. Therefore, there are no lines in the left side view projection. Through this study, we have learned about the combination forms of assemblies, surface connection relationships, and their drawing conventions. This will help us further interpret complex part drawings. Alright, that's all for today's study. Welcome to continue following our drawing interpretation micro class. Goodbye.